Okay, let us make a complete diagram relating all the coordinates together now. So it's going to be important to be able to switch back and forth when appropriate, depending on the problem, between XYZ coordinates, between Z R theta coordinates, and now between theta rho and phi coordinates. So if we need to understand all of those things, we should draw a picture. I think for your own notes, you're going to need to draw this picture rather big because there's a lot of stuff going on in it. So I'm going to start by drawing the x-axis like this, and the negative side of the x-axis I won't draw very long at all intentionally. So there's not very much back here or there, just because it'll get in the way. Okay, y-axis and then a z-axis. All right. What I'd like to do is I'm going to go ahead and sort of back pick a point to make the picture work out nicely, so that, you know, that sort of little piece of the x-axis often gets in the way. So I'm just going to intentionally just draw kind of away from there somewhere. That I don't think worked very well. I'm going to maybe go this way. Okay, so then there's a point here. Now, this is the point I want to talk about, all right? And let's say that this point is found by being directly above, let's just say maybe, how about, let me remove some of these dots actually. How about right here? This is a point that's on the xy plane, and how far? Well, we've got that, and I'm going to draw these dotted lines parallel to the y-axis this way. We've got that. Okay, so we have x on the x-axis, the y-coordinate y on the y-axis. Of course, we could... Ooh, this did not work well. Well, let me try this. Let me try deleting a little of this just so that I can attempt to get all things labeled a little better in this picture. Should have thought about this. Whoopsies. We'll just do that. Sorry to do this way. So if I draw this back here, let's say that that's the z coordinate. Okay, so then the length of this here, maybe I'll draw this in another color. Okay, the full exact length of this line segment that connects the point to the origin, that distance is rho. Okay, z, by the way, there's another place that we could label z, and I'm going to go ahead and do it. It's the length of this dotted line segment here. Okay, that's another place I mean, it's the same as this distance. It's just drawn here, and those should be exactly the same, but I don't know if I did really perfectly in the picture for that. Okay, then that same blue line segment that we've drawn in thick here, right? It creates an angle with the positive z-axis. So I could label that maybe like kind of right here, and that angle this way is phi. Also, in the xy plane itself, okay, in the xy plane, there's I'm just going to draw from the origin to the point that's down here directly below this point up here. Right? So we've got the point we want, and directly below there's this point in the xy plane. So the angle right there from the positive x-axis just up to where this line is here, that's theta. Okay, and then the this dotted line here, okay, that distance right there is r. All right. Now, I'd like to pick out just part of this diagram here. So what I'd like to do, maybe down here, is there's so much stuff going on in this picture. I'd like to focus on part of the picture here. So I'm intentionally just going to draw just the origin, the positive z-axis. I'm going to draw the point that we want. I'm going to draw the line segment connecting. This is rho, This angle here is phi. Of course, we could label that same angle down here if we wanted. So that I hope you're seeing this part of the diagram, this point down here, and then I'm going to draw in R, this segment this way, and then I'm going to draw in Z here. So that is, I'm going to do this. So this is just the Z axis label, but this is this dotted line drawn down here, Z, and then this way, this is just a copy of that red line segment there. So this is R. I should point out that it's maybe not too clear in the picture, but there's a right angle right here. Where is that right angle? It's this and that, right? It really has to create a right angle because this one is completely in the xy plane, whereas this one is completely vertical because we took the point we actually care about and looked at the point that's directly underneath. So there is a right angle right there. Okay, so I tried to draw just parts of that picture here, but I'm going to actually now redraw it again. Now that we have the part of the diagram that we want, all I'd like to do is just rotate kind of where we're drawing it a little bit, like so that if I just stood over here and looked at it, so that we have the chance of just drawing it flat, I think it will look like this. So here's the positive z-axis again. That part is even less important, so that's why I'm drawing it in dotted. This part here I've just drawn in dotted. But if we just flatten the picture, or really just view it from the right place, then we would be able to see this flat. We would actually have this right triangle. Let me just draw this in first. Okay, it's just a good old right triangle right there. We have R down here. We have rho there. We have Z here. You've got two parallel lines, and so the angle phi that appears here, due to an old geometry theorem, phi should appear right there too. And if you just eyeball it, that's got to be phi anyway, right? So here's what we're going to do based on this right triangle right here. I'd like you to look at sine of phi. Okay, sine of phi. So based on this angle, we need opposite over hypotenuse, right? So R over rho. So sine of phi is equal to R over rho. What about cosine of phi? So from the diagram, we need adjacent over hypotenuse. So we need Z over rho. Now, let's take each of these equations, multiply both sides by rho. So you have rho sine phi equals R, and you'll have rho cosine phi. Rho cosine, where did this theta come from? This should be a phi. I apologize. Yeah, there's no theta here at all, sorry. So rho cosine phi is equal to Z. Okay. And then let's also recall back from polar and cylindrical, and x is equal to r cosine theta. So this theta is a polar coordinate, it is a cylindrical coordinate, and it is a spherical coordinate. Okay, so x equals r cosine theta, y is equal to r sine theta. And let's do something with this. Here's what we can do is let's, based on this, I'm going to rewrite x equals r cosine theta, except I'm going to make a replacement. Instead of writing r, I'm going to replace the r with rho sine phi, which we have right here. So the r that, let me use some color just to make this clear. So this r that's right here, I could replace r with rho sine phi. So I'll have rho sine phi times, there's still a cosine theta. Okay, what about y? Well, again, let's replace that r right here with rho sine phi, and then still need to copy sine theta. Okay. So this is good. This is rather important that we have these two equations, and we'll take a look at that in the next segment.